Alright, let's go ahead and look at rational zero theorem problems solving using rational zero theorem. List all the possible rational zeros. So according to rational zero theorem, the possible zeros of a polynomial would be factors of the constant term, which is 6, over factors of the leading coefficient, which is 3. So in this case, the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of 3 are plus or minus 3 and plus or minus 1. Therefore, all the possible factors would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 3 over 3, which is 1. I have plus or minus 6 over 3, which is 2, so I don't need to include them. Find all the zeros of the function x cubed plus 4x squared minus 3x minus 6. First, let's list all the rational zeros, which are factors of negative 6 over factors of the leading coefficient, which is 1. And that would be factors of 6 would be again plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Factors of 1 are plus or minus 1. So now the possible factors here are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So now we're gonna use synthetic division to find the rational zeros from among the list of the possible zeros. So let's go ahead and try some of them here. The first thing I would try here would be I would try negative 1. So I'm gonna try, you can try anything, but I just use my calculator and I found that negative 1 is a 0, so I'm gonna try negative 1 first. So if I try negative 1, I would have 1, 4, negative 3, negative 6. Remember, these 1, 4s, negative 3s, and negative 6 come from here. And synthetic division, you bring down the first number. 1 times negative 1, negative 1. Negative 1 plus 4 is 3. 1 times negative 3, negative 3. Negative 3, negative 3, negative 6. Negative 6 times negative 1 is positive 6, and 0. Because the remainder is 0, I know this is a factor. But remember, one factor leads to another. So if negative 1 is a rational zero, that means x plus 1 is a factor. And what is the other factor? X squared plus 3x minus 6. So now these are the factors of the polynomial x cubed plus 4x squared minus 3x minus 6. And here, remember, the first 3 numbers in the bottom row of the synthetic division, they give us the coefficients of the other factor. So therefore, these would give us the other factor, which is x squared plus 3x minus 6. Now I am going to go ahead and see what was my function. The function f of x was x cubed. Let me go back and check. X cubed plus 4x squared minus 3x minus 6. Is that what it is? Yes. Now that, using the synthetic division, I factored it to x plus 1 times x squared, what was that? Plus 3x minus 6. Right? So now I cannot factor x squared plus 3x minus 6. It is not factorable, so I use quadratic equation, or the quadratic formula. What is the quadratic formula? Minus b plus or minus square root of b squared minus 4ac over 2a. So x is equal to minus b plus or minus b squared minus 4a and c over 2a. And that would be negative 3 plus or minus 3 squared minus 4 times 1 times negative 6. That would give me radical 33 over 2. So now my factors are negative 1, negative 3 minus radical 33 whole thing over 2, and negative 3 plus radical 33 the whole thing over 2. Solve x cubed minus 2x squared minus 11x plus 12 equal to 0. So first I'm going to list all the possible rational zeros, which would be factors of 12 over factors of 1. That would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12 over plus or minus 1. So now the possible ones are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now I'm going to use synthetic division to find a rational root from among the list of possible roots. So in this case, I would try 1. I'm going to try 1. And again, you can try any number you want, but I'm just going to try 1 here. 1 minus 2 minus 11 plus 12. Synthetic division, I bring down the first term. 1 times 1, 1. Negative 1. Negative 1 times 1 is negative 1. Negative 12. 1 times negative 12 is negative 12. 0. Bingo. So 1 is my root. So I know that if 1 is the root, x minus 1 is a factor. Okay, now rewrite the equation in the factored form using the bottom row of the synthetic division. So how would I get that? Remember, the bottom row of the synthetic division that gives the coefficients of the other factor. So the coefficients are x squared minus x minus 12. Right, so one factor is 1, the rational 0 is 1, so the factor is x minus 1. And this is another factor which would be in this form. Right, so now I'm going to go ahead and see if I can factor this. So this is going to be x minus 1. Let's go ahead and see if I can factor x squared minus 12. That would be x minus 4 and x plus 3 equal to 0. So setting x minus 1 to 0, I get x is equal to 1. And setting x minus 4 to 0, I get x is equal to 4. And setting x plus 3 to 0, I get x is equal to negative 3. So the possible the zeros of this polynomial, not the possible, the zeros of this polynomial are 1, 4, negative 3. Or these are nothing but the zeros are also the x-intercepts of the polynomial. Find a fourth degree polynomial function f of x with a real coefficient that has I and 3i as zeros such that f of negative 1 is 20. Because here we are using the linear factorization theorem to find the polynomial. So now because we're using that and because they say I is a 0 and 3i is a 0 of the polynomial, we can use the linear factorization theorem, and we know that if I is a factor, then the conjugate negative I is also a factor. If 3i is a factor, then negative 3i is also a factor of the polynomial. So now rewriting the polynomial f of x using the factors and using linear factorization theorem, an. Remember, it's a fourth degree polynomial, so I should be having 4 roots. So if one root is I, then x minus I is a factor. If one root is negative I, then x plus I is a factor. If one root is 3i, then x plus I is a factor. If one root is 4i, then x minus I is a factor. If one root is 6i, then x minus 3i is a factor. If one root is negative 3i, then x plus 3i is a factor. So now I'm just gonna rewrite them here. So the polynomial would be x minus I, x plus I, x minus 3i, x plus 3i. And when I go ahead and multiply them, what do I get? I get an is I times I is I squared, so this is going to be x squared plus 1. These are conjugates. When I multiply x minus 3i and x plus 3i, I get x squared plus 9. And when I go ahead and multiply that, I need to FOIL this one. I get x squared plus 9, no, x power 4 plus 9 plus 10x squared. And that's what I'm going to be getting. And now this is the polynomial. But remember, I don't have the coefficient an. What did they say? They gave me a hint. They said f of negative 1 is equal to 20. Now let me go ahead and use that to find the value of an. F of negative 1 is equal to an times negative 1 to the power 4 plus 10 times negative 1 squared plus 9. So an would be negative 1 times negative 1 times negative 1 is 1 plus 10 plus 9. So an times 20. What is f of negative 1? F of negative 1 is 20. So 20 is equal to 20 implies an is equal to 1. So my function f of x is equal to x power 4 plus 10x squared plus 9. Determine the number of positive and negative zeros of f of x. F of x here is x cubed plus 2x squared plus 5x plus 4. Remember, we're using the Cotter's rule of sines. So first I'm going to go ahead and write f of x, which is x cubed plus 2x squared plus 5x plus 4. And I'm going to find f of negative x. That's my second step. What is f of negative x? Negative of x cubed plus 2 times negative x squared plus 5 times negative x plus 4. And what would I end up with? I would end up with negative x cubed plus 2x squared minus 5x plus 4. So according to the rule, I'm going to count the number of sign changes in f of x first. From plus to plus, no change. Plus to plus, no change. Plus to plus, no change. So f of x has no sign changes. That means f of x has no positive zeros. Has no positive zeros. Now let me check f of negative x. Negative to positive, one sign change. Positive to negative, one sign change. Negative to positive, one sign change. So that means since f of negative x has 3 sign changes, it would have 3 negative zeros, or remember 3, or you're going to take away even number from 3, which would give me a 1. So it would either have 3 negative zeros or 1 negative zeros, since it has 3 sign changes. So we would have 3 or 1 negative zeros.